Hello everyone, welcome back to my channel Electrical Concepts. My name is Vigyan Roy. So in this video lecture, I will be talking about back EMF constant and torque constant. Okay, so many people have the confusion between these two constants. These two constants are widely used in case of DC motors, and many people have the confusion that these two constants are same. Okay, so some people say not, no, they are not same. Okay, so in this video lecture all the things will be clear. Okay, so please watch till the end. So let's start. So as we all know, this is the well known equation of back EMF for DC machine. Okay, especially say DC motor. So EB is the back EMF and it can be written as phi p Zn by 60A. Phi is the flux per pole, P is the number of pole, Z is the number of conductors, N is the speed in RPM, and A is the number of parallel path. So these things you already know, right? So now see, for DC shunt motor, okay, I am talking about DC shunt motor. You can also consider DC series motor, but in that case things will be little bit different, because in case of DC series motor flux is not constant, it varies with the current. Okay, but in case of DC shunt motor flux is constant. So this difference is there. So for DC shunt motor, your back EMF EB can be written as KB multiplied with N, where KB is phi p Z by 60, and this is a constant term, because for DC shunt motor flux is constant, so this entire term becomes constant. But in case of DC series motor, flux will not be constant, so this little modification will be there. Okay, so this KB is called the back EMF. Okay, KB is the back EMF whose unit is voltage per RPM. Here N is the speed in RPM, so we can say the unit of KB will be voltage per RPM. Okay, and for the time being, let's consider this nomenclature. Okay, so this back EMF constant is given a nomenclature, say KB RPM. Okay, I will tell you later why this nomenclature is given here. So now this is a very important point. What is the actually physical significance of back EMF constant? See, it indicates the change in back EMF for a unit's change in speed. See, KB can be written as back EMF divided by the speed, right? So it actually signifies that what will be the change in a back EMF for a corresponding unit change in speed. Okay, that means suppose in your motor there is a change in speed. Okay, so what will be the corresponding change in back EMF? Or we can say there is a change in back EMF, what will be the corresponding change in speed? These things can be analyzed using this back EMF constant. Now let's come to next point. Now see, interestingly, back EMF can also be expressed as this. See, speed can be expressed in two ways. One is in RPM and one is in radian per second, which you call omega, right? So when it is omega, then the equation becomes like this: EB is equal to phi p Z omega by 2 pi A. Okay, why? Because there is a relation omega is equal to pi by 30 into N. So if you put this value of N in this equation, and then you will get this equation. Okay, so where omega is the speed in radian per second. Alright, so now you will get to know that why I have given that nomenclature KB RPM, because see, here also you are getting one back EMF constant. Here also you can write EB in this fashion. Okay, KB radian per second into omega, because here speed is in radian per second, and here the back EMF constant is phi p Z by 2 pi A. Okay, so now let's see what is the relationship between these two back EMF constants, KB. Okay, so KB radian per second is the back EMF constant whose unit is voltage second per radian. Okay, therefore we can say, by relating these two equations, we can say the KB RPM is pi by 30 multiplied with KB radian per second. So this is the equation of, this is the relation between these two back EMF constants. Okay, KB RPM is equal to pi by 30 multiplied with KB radian per second. Okay, so if you are given KB RPM, then you can easily convert it to the KB radian per second. Okay, so this is the relation. So this is all about the back EMF constant. Now let's come to torque constant. Okay, so now we know this formula. P output is equal to omega into T means torque, and this P output can also be written as EB into IA, mechanical equivalent power. Okay, so by making some manipulation, we can find the torque T is equal to 5pz by 2 pi a into IA. Okay, so for DC shunt motor, we know torque is directly proportional to armature current because their flux is constant. For DC series motor, torque is directly proportional to I square. So these small modifications are there, but for DC shunt motor, torque is directly proportional to the armature current, and KT is nothing but your torque constant, where KT can be represented like this, 5pz by 2 pi a. KT is the torque constant whose unit is Newton meter / ampere. Why? See here, KT can be written as torque by ampere, right? So unit must be Newton meter by ampere. So this is the unit of torque constant. And what is the physical significance of torque constant? See, it indicates change in torque for unit change in current. Okay, that means whenever there is a change in current, there must be a change in torque, or whenever there is a change in torque, there must be some change in current. So that can be analyzed using the torque constant. Okay, so for a unit change in current, what is the change in torque? That can be indicated by the torque constant KT. Okay, this is the physical significance. So now see this expression. Okay, see here, now you got all the values. You know what is back EMF constant. There are two back EMF constants, one is in radian per second, one is in RPM. You also know what is the expression of torque constant. Now you can easily relate those things, right? So if you relate, you will get this expression. Okay, so torque constant is exactly same as the back EMF constant at radian per second, but that torque constant is not same with the back EMF constant in case of RPM. Rather, T, that means torque constant, is equal to 30 by pi multiplied with kb RPM. Okay, so now I think your confusion is clear. Many people say that torque constant is same as the back EMF constant. Many people say no, they are not same. Okay, now this confusion is clear, I guess, because see, it completely depends on which back EMF constant you are referring. If you are referring the back EMF constant on radian per second, then yes, definitely your torque constant and back EMF constant both are same. But if you are referring the back EMF constant in RPM, then they are not same. Then KT is equal to 30 by pi into kb RPM. Okay, so I hope now you have no other confusion. Now these things are completely clear to you. Okay, what is the relationship between torque constant and back EMF constant? Okay, so I hope you have liked this video, and please subscribe to my channel. Okay, also share, comment, and in next video lecture I will come up with some more interesting concepts like this. Till then,